looking at one of our more advanced visual AI solutions that we've deployed in the plant. This one, the F37 material detection system, looks for what material we've got on our main feed conveyor going to the number 5 stockhouse and compares that to what material we think we have on the belt.
We've got our primary and secondary yards where material comes off the ships and we stack it out into the various discrete piles, as well as where we collect the raw materials coming from the cinder plant and our coke ovens.
Feeding the blast furnace, we've got our number 5 blast furnace stockhouse, where all the materials for the charges are weighed out and mixed. Those materials include coke, sinter, lump ore, limestone, quartz, nut coke, so a variety of different materials. And they're all fed into the stockhouse through the one main feed conveyor, F37.
For some of those materials, they stay in those stockpiles until they're ready to be loaded directly into the blast furnace stockhouse, where a front end loader will, depending on the material that's been selected, come along and start scooping up those materials and putting it into a weigh hopper that gets elevated up into our stockhouse. So for this project, we really want to make sure that the material they've been told to pick up is the same material they're picking up, and that the bin that we've selected the material to go into is the right bin for the material that's on the belt.
It's really important we know if we've got contamination of those materials before they end up in the furnace, so we've got a chance to do something about them.
We've installed a standard CCTV spec camera over one of the belts that is part of the elevation sequence, ferrous sequence.
We've taught a system how to identify what type of materials it will see in its normal life. So we've trained it against what we expect versus what it can see.
We collect images. What we do, we go through a process where we label the images, so we tell the model what each material is, and then we build up a sort of repository of those images, and then we put that through a training sequence where we pass it what the labels of the images are, then we pass the images in, and machine learning will go through a few iterations of learning what each material looks like. With the more images we add, it ends up getting very, very good at being able to distinguish between each individual material.
We've made it visible to the operators in the control room here. It's because previously the controls for the material going to the furnace are largely administrative, asking the front end loader driver to pick up the correct material, and a little bit hopefully he doesn't make a mistake, whether it be at night time or daytime. With this new system in place, we can now give that feedback directly to the operator in real time to know if the material going into these bins is right or wrong. So when it does detect that mismatch, where the conveyor is, it's a flashing red words material mismatch. So red's a colour that immediately attracts the operator's eyes. You can see it straight away and react to it quickly, as opposed to before where there would be little or no reaction, or it relies on a camera from a very large distance trying to determine if there's a different material. Now it's straight in their face and we can do something about it as soon as possible. It's all about the results, not just from now but for the future. It's just preventing all bin contamination, or at least if there is bin contamination, we know about it and can act on it in the furnace level, in the furnace chemistry. And it's got repercussions not just for now but over for number 6 blast furnace. It's a solution we can easily just implement, pick up and move, and then so it'll benefit up until the end of number 6 blast furnace, and potentially whenever we use material conveyor sequences similar to this anywhere on plant.